Welcome back. So the next question that we are taking on is binary tree right side view. This question is tagged as medium and it has a successful submission rate of 60%. The question is about given a binary tree, we have to return an array that contains the node values from top to bottom as if we are looking at the tree from the right side. So we are looking at the tree from the right side. The values that we see is 1, 3, 4, and we have to order them in top to bottom manner. So think about it for a moment, and then we can start discussing the approach. Well, I think this question is pretty straightforward and a true demonstration of how powerful traversal identifying the right traversal technique is. So, like in this problem, if I were to think about depth first search, um, I don't feel it's right. But the moment I think about breadth first search, it immediately clicks and everything sets. So in the breadth first search, I'll be traversing in levels, right? And in each level, I move from left to right. So I'll move from left to right, and in the from top to bottom. So what I have to do is in the each level, I have a node count. So here the node count is 1, here the node count is 2, and here the node count is 2 as well. So before I move on to the next level, I will just simply append the node value to the output list, output array. So that is it, pretty much it, right? We are moving from left to right. So in this, we are moving from right to left to right. We are on 1 and we are about to move on to the next level. Next level, yeah. So before that, I'll just simply add 1 to my output. I'm now on the second level here, and then I'll traverse from left to right again. And before I'm about to move on to the next level, I'm on the rightmost node, and I'll simply just append the value to the output array. Now I'm on this level right here. I'm moving from left to right, and before I do anything, before I am ready to move on to the next level, that is I am on the rightmost node, I'll simply add the value to the output array. So in terms of logic, it is quite straightforward. Use breadth first search, and before moving on to the next level, simply add the node value to the array. Now we will implement this on our editor and see through the logic so that we are crystal clear what the solution is. So let's begin. It's all about breadth first search. So the base condition is if there is no root, just return. Otherwise, we will proceed with the breadth first search, that is queue and root as the only element in the queue. Result is going to be the output that we are going to return, that is the array. And while the length of queue is not equal to 0, we will enter the loop where we perform the breadth first search. Node count is equal to len of queue, so that we are performing operations in a level. So this loop will make sure of that while node count is greater than equal to 0. Everything that happens inside this loop is going to be performed on the level. So I'll pop from the queue, from the front of the queue, check if there is a left child, and if there is one, I'm going to append it to the queue, and then I'll do the same for the right child. And node count minus equal to 1. So when the node count is 1, or when node count minus equal to 1 makes the node count from 1 to 0 and we exit the loop, we are on the rightmost node of that level. And what we want to do is we want to append the value of that node to our result array. So let's do that. So I'll get out of the loop and do a result.append node.val. And then finally, I want to just return the result array as the output. So I'll just run this code and check if there is any error. No, there's not. So let's test all the test cases. And it's working. So with that, we are through with this question, our first medium question, and it was pretty easy, we can say, because we took proper steps. So that is it. Thank you for watching this video.